All right, page 99, we're talking about bisectors of triangles. We've done this. We've constructed it. Let's just stop and make sure you're understanding what you're actually constructing. So this very part of your vocab is let's sketch it. Just like on the warm-up, let's do a perpendicular bisector. Let's do a right triangle. So sketch yourself a right triangle. I'm going to do mine this way, like here, hypotenuse, don't forget your 90-degree angle. Okay, this was part of your quiz. When we do the 3 perpendicular bisectors, do you remember where all 3 of them meet? Where? On the right triangle. Do you remember where on the right triangle? Okay, this is going to be rough sketching it. We'll just do our best, right? Okay, so perpendicular, it has to be 90 degrees, but it also has to bisect it, so it has to cut it in half. Here we go. That's where I always start if I'm just sketching it without a ruler. So I look at this, halfway might be like right here. So I always put it in my midpoint, and then I put my symbols. That's congruent to that. And then I do my perpendicular bisector. Whoa. There we go. Don't forget your 90-degree angle. Okay. Again, don't forget perpendicular. It's got to be 90 degrees. I'm going to do this next leg right here. Maybe like right there. We're going to call that the midpoint. Don't forget to put in your symbols. So that's the midpoint. Those 2 pieces are equal. So that means like right there. Don't forget your 90-degree angle. The last one. If I'm ever just sketching it, don't you think that this third one should meet where the red and the green are meeting? Yes. So I use that to my advantage. I'm like, all right, well, it's probably going to go right here. Okay, don't forget your congruent symbols. This piece will be congruent to that piece because that's the midpoint. Okay, when I was correcting your quizzes and your sketches on the pad of paper, I saw some weird things for the 90-degree angles on this part. Because what he just did, this black line is perpendicular to this blue hypotenuse. So your 90 degrees should just be the black to the blue. I saw weird stuff. I saw 90-degree angles outside of the triangle. It was just weird. I don't know where that came from. Be careful. Okay, now if you can, if you have more room than I do, emphasize this, their intersection, like Annie did on the warm-up. That's what we're talking about today. It has a name where all 3 of those meet. We'll get to it. Looks pretty good. How many of you have a pretty good looking picture? Yeah? All right. Next one, concurrent lines, point of concurrency, because this is one picture that goes for both of them. So concurrent lines are 3 or more lines that intersect at the same point. So just sketch 3 lines real quick. 1, 2, 3 lines, and they all intersect at a point. So concurrent lines, put a box around it. Concurrent lines is focused on the lines. 3 lines that intersect at one point. Point of concurrency is emphasized. It's the same picture, but this is emphasized. Put a box around it, around the point. One, you're focusing on the lines. The other, you're focused on the point. Okay, here we go. New vocab word. Circumcenter. The circumcenter of a triangle, because that's where all 3 perpendicular bisectors meet. If you want to add it in your notes, where all 3 perpendicular bisectors meet. You okay if I use that upside down T for perpendicular bisectors? I'm going to put intersect. So right here, our purple dot, that's the circumcenter. We've constructed them, we just didn't name them circumcenters. Question, Ellie.
So it's technically that point is the circumcenter, but it's also the point.
Yes, Ellie's question was, it's the circumcenter at that point, but it's also the point of concurrency. Perfect. Okay, let's sketch angle bisectors real quick. Let's just do an acute angle for this one. Excuse me, acute triangle. Let's draw yourself an acute triangle. Same thing on your quizzes. I saw you doing weird stuff. And then heads up, some of you just did perpendicular bisectors again. No, these are angle bisectors. So draw now to this huge. This is focused absolutely only on the angles. You're bisecting an angle. Remember, bisect just means cut it in half. So start at one angle and then just eyeball it, try to get right in the middle. My pen's a little bit off. Huh, not too bad. Literally cuts that top angle right in half. Put in your symbols. Congruent, congruent. And then try again. Do your best, just eyeball it. Try to go in the middle of another one. Put in your congruent symbols, so we cut this angle in half. And then last one again, I'm really nice to myself and I think, all right, my last one has to meet where that purple and green are meeting. Hopefully I can handle it. I like that. That's a little bit off. There you go. Okay, so where do you think all three angle bisectors always meet in any type of triangle? They always meet inside because you're coming off the angle, so you can't ever go outside the triangle. You're cutting the angles in half. That's it. That's all you need on the picture for angle bisectors of a triangle. All right, so where they meet, the point of concurrency is right here. Guess what? That's the in-center. In-center is for angle bisectors. Circumcenter is for perpendicular bisectors. You want to add that in-center where all three angle bisectors intersect. So in the morning class, this is what we talked about. How can we remember circumcenter, in-center? And it came up, there's a trick for in-center. So right here, move it. Or in-center, if you just use the letters, we thought of a trick. In-center, and then you line it up with angle bisector. Or perpendicular bisector. I'd say looking at it, I kind of feel like there's a match if you just look at the letters of it. Are you watching? It's kind of a stretch, but maybe it'll help you. We'll do whatever we can to help. If you look at these ones, just the first two, whoa, right there. Do you see these ones kind of look like they match each other? In and, that's how I would remember it. In-center, angle bisector. If it helps, go for it. If it doesn't help, good luck. You got to think of your own trick. In-center always goes with angle bisectors. And then circumcenters goes with perpendicular bisectors. Okay, let's see. Oh, this is really helpful, really convenient if you can remember it. So if we're talking about perpendicular bisectors, these two perpendicular bisectors meet right here. Guys, practice it. Letter P, what's the vocab word for letter P? It's the, which one? I heard both. I heard circumcenter and I heard in-center. Which one is this one? This one's the circumcenter because it's the perpendicular bisectors meeting. Guys, write it in your notes. Practice, practice. The more you practice, the easier it will be. All right. So point P is the circumcenter. What this theorem is saying is if you go from the circumcenter to the vertice, draw on your notes right here. P to A, P to B, P to C, they're all going to be congruent. Do they look like they're congruent? Logically, yes. But you always got to remember, go back to the vertex. Now, be very careful, because some of you are going to try to say that these ones are congruent, highlighted in blue. Look at those ones. Do they look like they're congruent? No. From the circumcenter will always be exactly the same. Quite convenient. This one, here we go. Real life situation. And your friends are in separate boats, and there's a buoy between you, but it says, wait, pause. Do you guys know what a buoy is? Wait, boaters? Okay, the little floaty thing, right? Okay, so where's the buoy if it's equidistant from all of your boats? Because you have this in your notes, don't you? Do you have little dots? I'm like missing dots on here. Okay, so put in your dots. So we can either use the angle bisectors or the perpendicular bisectors to figure out where the buoy is. Okay, angle bisectors though. Angle bisectors, they all meet where in any triangle? Inside the triangle. I kind of feel like the buoy is not in between our boats. So let's use the perpendicular bisectors. But what's the vocab word for where they all meet? Practice it. What is it? Yes, write it in right here. Let's try for the circumcenter. Okay, first get yourself a triangle. Connect your boats. Okay, same like we did on the vocab and same like we did on the warm-up. Just eyeball it. Try to do the perpendicular bisectors. Good luck. I always start with the midpoints. So I'm going to go from boat 1 to boat 2. Eyeball halfway between, maybe like right here. Put in your symbols. That's the midpoint, so those two broken pieces are congruent. Add in your 90-degree bisector. Check. All right, let's see. I'm going to try for boat 2 to boat 3 next. So halfway between those, eyeball it maybe like right here. Put in your symbols. All right, 90 degrees. We'll make a T. It's maybe a little bit like this. That's a little bit stretched. Do your best. Okay, last one. If you're being nice to yourself and you know that you don't have your ruler or your protractor, you're just eyeballing it. Well, they have to meet where that blue and green are meeting. So I use that to my advantage. I'd say like right there. So this is our 90-degree angle. That looks pretty good. This is congruent to this. There you go. You just found the buoy. The buoy would be right here if it's equidistant from all of those. Crazy, huh? Really is used. Okay, let's go to that next picture. Again, be nice to yourself on the next picture. Sorry, ask me again. You know what? I think this is Abigail's question. Perpendicular bisectors of this triangle, shouldn't they meet on the triangle? I kind of think it might be obtuse. Do you guys think that's an obtuse triangle? It's like barely stretched out. And only obtuse always meets outside, right? I think because if you look at boat 2, boat 3, they're a little bit off. They're not quite straight up and down. Okay, here we go. Perpendicular bisectors again. So if these are a picture, this is a picture of perpendicular bisectors. Guys, nice and loud, point S. What's the vocab word for it? Just keep practicing it. I know you feel like dorks, but it's okay. Practice, practice, practice. So S is the circumcenter. So right here, check it. I keep begging you, draw on your pictures. Highlight this and highlight this. PS and QS. Here's PS. Here's QS. Look, they're both going from a vertex to the circumcenter. Do you see that? So find another one that we didn't highlight that's going from the vertex to the circumcenter. What is the one that we haven't highlighted yet? Yes, yes, yes. Do you agree? RS is the third one? Okay, we talked about the theorem, or just look at them. What do you think is the relationship between RS, PS, and QS? They're all congruent, so check it. They gave you RS. RS is 10, so what does PS and QS have to be? 10. So as long as you notice it, these can be really friendly questions. Again, just draw on your pictures, see if you can figure it out. Okay, perpendicular bisectors, we went crazy with them. Let's go to angle bisectors now. So picture of angle bisectors. Here we go. Where all the angle bisectors meet is right here. P. All right, practice it. Do you know what point P is called, the vocab word? Good job. In center. A-N-I-N. This is the in center. Okay, this one's a little bit different because we've got angle bisectors. Angle bisectors, what you do with these ones, PD, you go back to the side and you create a 90-degree angle. Stop and think about this. Is this bisecting this leg right here? Not even kind of, right? All you do is go from the in center, 90 degrees back, 90 degrees back, 90 degrees back. Look at those. What do you think is going to happen to all three of those red pieces? They'll be equal, they'll be congruent every single time. So PD is going to equal PE is going to equal PS. Once you won't know one, you can figure out the other three. Okay, the next example in your book, it's that big, tall triangle. Because if you want, you can totally write in the margin, if you want more room for this. Watch, let's show it. Actually, before I show you, because do you remember, raise your hand if you remember doing Pythagorean theorem the very first week of school. Do you remember? Some of you remember? How many of you, just me saying Pythagorean theorem, do you remember how to do Pythagorean theorem? So maybe we need a review. Okay, first thing with Pythagorean theorem, it only works for what kind of triangles? Has to be a right triangle. Keep that. Okay, here we go. We've got a real tall triangle. Letter A says what segments are congruent. Do Do you need a hint? Somebody know which ones are congruent in this one? Colton, do you want to try? Go ahead. MH, PH, NH. What do you think about Colton's guess? Do you think those will be congruent? Yes, write it in your books. So he said MH congruent to NH congruent to PH. Good job, Colton. All right. Next part, it says find HN and NP. All right, let me erase this. Well, do you agree? Once we know HN, we know HP because they should be the same thing, right? So let's just find one of them. So I'm going to highlight a triangle and see if you can see something. Highlight this one in your book. Super tall one. Because I think we know 2 of the 3 things of that triangle. And what does that leg equal? Hint, hint, hint. Okay, what does the hypotenuse equal? Right there, 20 mean? Is this x right there. Do you see that? Okay, with Pythagorean theorem. Pythagorean theorem is always leg squared plus leg squared equals hypotenuse squared. So remember, hypotenuse squared is always the biggest one, the one that's across from the right angle. So let's set this up for ourselves. So leg squared, x squared plus leg squared, 24 squared will always equal the hypotenuse squared. Don't forget to square them. So in this equation, we'll have x squared plus, hand in the air, help me out, 24 squared, I want to guess, but it makes me nervous. Kelsey, what is it? 526 or 576? 576 equals 25 squared. Double check me, is 25 squared, 25, 625?
Yeah.
Okay, equals 625. Solve it just like you normally would, algebra skills, so subtract that 576 from both sides. I think this comes out super friendly. So x squared equals, shout out, what is x squared? 49. So to get rid of that square, you gotta take the square root. Taking the square root, you just think to yourself, what times itself equals 49? Did you hear Colton? Totally 7. So x is 7. So that means HN is 7. What else is also 7? Yeah. There you go. You can use Pythagorean theorem whenever you want to, as long as it's the right triangle. Then you can use it. Okay, any questions on this one? Okay with that? Let's do one more example, that very bottom one. So look at your picture. Look at what it's asking. So these are the angle bisectors. It's saying find the value of D, but look what they gave you. They gave you this piece, 2D plus 7, and this piece, 4D minus 1. Does anybody remember the relationship between those 2 red pieces? They're equal. So again, let's just set up an algebra problem. So this will be 2D plus 7 is going to equal 4D minus 1. Okay, go for it, solve it. I'll show me work on the board, but try to beat me to it. Try it, try it. Okay, read on if you have the same thing. Again, draw the pictures. Hopefully it'll help you notice stuff.